Hello and welcome to Prepspot. In this video, we are going to know about a topic that stands at the crossroads of national security, economic development, and technological self-reliance, India's aircraft manufacturing future and the ongoing debate about achieving self-reliance in this critical sector. As we discuss this, it is important to understand that the evolution of India's aerospace capabilities has been a long and complex journey that began in the 1950s. Back then, the government established Hindustan Aeronautics Limited (HAL) to reduce dependency on foreign aircraft, and over the decades, India has made notable strides with projects such as the HF-24 Marut in the 1960s and the Tejas Light Combat Aircraft (LCA) in the 2010s. However, despite these advancements, India still remains heavily reliant on imports for both military and civilian aircraft, with defense imports reaching approximately $10 billion in 2024. This has raised important questions about whether India can truly design, manufacture, and maintain its own aircraft, a vision that is not just about economic growth but also about national pride and strategic independence. The current discourse on this subject has been fueled by recent milestones and announcements. On 10 March 2025, HAL successfully conducted the test flight of the Bharat Jet, a 50-seater regional jet developed in collaboration with Tata Advanced Systems Limited (TASL). This event has been widely covered in the media, with industry leaders and policymakers heralding it as a significant step towards reducing import dependency and achieving greater indigenization in aircraft manufacturing. Adding to this momentum, in January 2025, the government announced a new policy aiming for 70% indigenization in aircraft manufacturing by 2030. This ambitious target, which includes separate goals for design and maintenance, with 80% indigenization in design targeted by 2035 and 90% in maintenance by 2040, has sparked intense debates in both public and expert circles. The policy is seen as a crucial element of the broader Make in India initiative and is designed to foster domestic innovation, encourage public-private partnerships, and attract foreign technology transfers, all while addressing the critical shortage of skilled aerospace engineers in the country. To provide some context, India's aviation sector today is at a crossroads. On one hand, the domestic market is booming, with projections indicating that by 2030, domestic air passenger traffic could reach 300 million, and the demand for new aircraft could exceed 2,000 units by 2040. On the other hand, the country continues to import a substantial portion of its military and civilian aircraft, which not only drains foreign exchange reserves but also limits the development of indigenous technological capabilities. For instance, while the Tejas LCA has achieved around 60% indigenous content as of 2025, there is a persistent gap in areas like engine manufacturing and advanced composite materials. This gap is a major hurdle in India's quest for self-reliance, and bridging it requires sustained investment in research and development, as well as a robust framework for technology transfer and skill development. The government's recent policy announcement, which also includes incentives for private sector participation and strategic partnerships with foreign companies such as Airbus, reflects a multi-pronged approach to addressing these challenges. The origins of India's aircraft manufacturing efforts can be traced back to the post-independence era, when the need to reduce dependency on imported technology was recognized as a strategic imperative. HAL was established as a state-owned enterprise with the mandate to design, manufacture, and maintain aircraft for the Indian Armed Forces. Over the years, India made commendable progress, but it has often been hampered by limitations in technology, a fragmented industrial base, and a shortage of skilled personnel. The development of the HF-24 Marut in the 1960s, for instance, was a landmark achievement, even though it eventually faced production challenges and operational issues. Similarly, the Tejas project, while a symbol of India's growing technical prowess, has highlighted the complexities involved in achieving complete indigenization. The Bharat Jet test flight in March 2025 represents not only a technical milestone but also a renewed commitment to the vision of self-reliance in aerospace. It demonstrates that with the right combination of government support, private sector involvement, and international partnerships, India can make significant strides toward becoming a major player in aircraft manufacturing. Let's now examine some of the key concepts and terminologies that are central to this discussion. First, the concept of indigenization refers to the process of developing and producing technology domestically, thereby reducing reliance on foreign imports. In the context of aircraft manufacturing, this means not only designing aircraft but also ensuring that maintenance, repair, and overhaul (MRO) services are handled within the country. The current policy target is ambitious, 70% indigenization by 2030, with further increases planned for the future. Public-private partnerships (PPP) are also crucial in this process, as they facilitate technology transfer and collaborative innovation between the government and leading private companies. Additionally, terms like offset policy come into play. This is a regulatory requirement that foreign suppliers invest a certain percentage of their contract value in the domestic industry, thereby promoting local manufacturing and skill development. Technologically, the aerospace ecosystem in India comprises a network of R&D institutions, manufacturing facilities, and MRO services. Key technical processes involved in aircraft design include computational fluid dynamics, CFD, for aerodynamics analysis and finite element analysis, FEA, for ensuring structural integrity. At HAL, supercomputers are used for simulation and testing to optimize aircraft designs. Furthermore, advancements in manufacturing techniques, such as the use of composite materials for lightweight yet strong aircraft structures and the application of 3D printing for producing intricate parts, are critical in enhancing production efficiency and reducing costs. For instance, the Bharat jet incorporates around 30% composite materials, which not only reduces weight but also improves fuel efficiency and performance. However, despite these advances, significant challenges remain, particularly in the domain of engine technology. While India has made progress in developing certain components, advanced engine technology remains predominantly imported, underscoring the need for further research and development. The economic and strategic implications of achieving self-reliance in aircraft manufacturing are profound. A fully indigenous aircraft industry would reduce defense import bills, boost domestic manufacturing, and create high-skilled jobs, thereby contributing to overall economic growth. Projections suggest that if India successfully develops its aircraft manufacturing capabilities, it could capture a significant share of the global aerospace market, potentially generating economic benefits worth billions of dollars. This would also have positive implications for national security, as self-reliance in defense technology reduces vulnerabilities and dependency on foreign suppliers. Moreover, such advancements can have spillover effects in other high-technology sectors, including electronics, IT, and advanced materials, thereby catalyzing a broader technological revolution in the country. The human resource challenge is another critical aspect. Current estimates indicate a shortage of around 50,000 aerospace engineers in India by 2025, while only 20,000 engineers are being trained annually. This skills gap presents a formidable barrier to achieving the ambitious targets set by the government. Addressing this issue requires a robust and concerted effort, including enhanced training programs, academic industry partnerships, and initiatives like the National Skill Development Corporation's programs tailored to the aerospace sector. By investing in education and creating a pipeline of skilled professionals, India can ensure that its aerospace industry not only survives but thrives in a competitive global environment. Let's now consider the broader historical and geopolitical context. India's aircraft manufacturing journey has been intertwined with its strategic aspirations since independence. The ability to design and manufacture indigenous aircraft is not only a matter of economic self-sufficiency but also a symbol of national pride and sovereignty. Over the decades, India has faced several setbacks, such as the challenges encountered with the HF-24 Marut and the delays and technical hurdles in the Tejas project, but these have also provided valuable lessons that are shaping current initiatives. The recent policy announcement in January 2025, which sets the target of 70% indigenization by 2030, reflects a renewed commitment to addressing these challenges head-on. It signifies an acknowledgement that while the journey has been difficult, the future holds tremendous potential for India's aerospace sector if the right investments and policy frameworks are put in place. Furthermore, this topic is not merely of technical or economic interest, it has significant geopolitical implications. India's ability to develop a robust and self-reliant aircraft manufacturing capability would enhance its standing as a major player in global defense and technology sectors. It would also strengthen its strategic autonomy by reducing dependence on foreign technology, thereby allowing India to pursue its own foreign policy objectives without being constrained by external pressures. In today's rapidly evolving global landscape, where defense and technology are increasingly intertwined, achieving self-reliance in critical industries like aerospace is a key element of national security and economic progress. Now, let's address some of the challenges and controversies surrounding this ambitious goal. Despite the promising milestones, such as the successful Bharat jet test flight, there are significant technological gaps that must be overcome. For instance, advanced engine manufacturing and the development of high-performance composite materials remain areas where India lags behind global leaders. Moreover, while public-private partnerships have the potential to accelerate progress, the regulatory and bureaucratic hurdles associated with such collaborations can slow down the pace of innovation. There is also a debate among experts about the timelines. While the government's targets are ambitious, critics argue that achieving 70% indigenization in aircraft manufacturing by 2030 may be overly optimistic given the current pace of technological development and workforce training. In terms of numerical data, it is estimated that defense imports in India for aircraft and related equipment were around $10 billion in 2024. With the new policy initiatives, there is a hypothetical budget allocation of 50,000 crore rupees for the period 2025 to 2030, up from 30,000 crore rupees in the previous 5 years, which is intended to boost R&D, manufacturing, and MRO, maintenance, repair, and overhaul capabilities. Additionally, projections suggest that India's domestic passenger traffic is set to reach 300 million by 2030, and there will be a demand for over 2,000 new aircraft by 2040. These figures underscore the enormous potential of the aerospace sector in India, but they also highlight the urgent need to overcome current challenges. On the technical front, the design and manufacturing processes are highly sophisticated. The design process involves computational fluid dynamics, CFD, for aerodynamics simulation and finite element analysis, FEA, for ensuring structural integrity. Advanced manufacturing techniques, including the use of composite materials and 3D printing, are being employed to improve efficiency and reduce production costs. For instance, the Bharat jet, which recently underwent its successful test flight, incorporates about 65% indigenous content, with plans to increase this figure to 70% by 2030. These technical details not only showcase the progress made but also emphasize the areas where further improvement is necessary, particularly in engine technology and materials science. Furthermore, the operational maintenance of aircraft, often referred to as the MRO ecosystem, is a critical component of self-reliance. India is currently developing MRO hubs in cities such as Bengaluru, Hyderabad, and Nagpur, with plans to expand to additional locations by 2030. The establishment of a robust MRO ecosystem is essential to ensure that the aircraft remain operational over their entire life cycle, reducing downtime and costs associated with maintenance. This aspect is especially important for the military, where operational readiness and reliability are paramount. Now, let's consider the broader societal and strategic impact of achieving self-reliance in aircraft manufacturing. For one, it would significantly reduce India's reliance on foreign suppliers, thereby saving billions of dollars in defense imports and channeling these funds into domestic industries. This, in turn, would lead to the creation of high-skilled jobs and foster technological innovation across related sectors such as electronics, IT, and advanced materials. Achieving self-reliance in aerospace is also a matter of national pride. It symbolizes India's ability to harness its human and technological resources to achieve complex goals, a sentiment that resonates deeply with the country's developmental aspirations. Furthermore, a robust indigenous aerospace industry would enhance India's strategic autonomy, allowing it to make independent decisions in defense and foreign policy without being overly reliant on external partners. Despite these promising prospects, there are significant challenges that need to be addressed. The shortage of skilled aerospace engineers is a major hurdle, with estimates suggesting a gap of around 50,000 engineers by 2025. Although training programs under initiatives like the National Skill Development Corporation have been launched, the pace of training has not been sufficient to meet the growing demand. Additionally, the regulatory framework governing public-private partnerships and technology transfer needs to be streamlined to ensure that innovative ideas are not stifled by bureaucratic hurdles. There is also a need to address the funding gaps and ensure that the substantial budget allocated for the sector is utilized effectively, with robust mechanisms for monitoring and accountability. To summarize, the future of India's aircraft manufacturing industry represents both a formidable challenge and a tremendous opportunity. With milestones such as the successful Bharat jet test flight in 2025 and ambitious government targets for indigenization, there is a clear commitment to reducing dependence on imports and building a self-reliant aerospace ecosystem. However, achieving these goals will require overcoming significant technological, human resource, and regulatory challenges. For competitive exam aspirants, this topic offers a multifaceted case study that spans economic policy, technological innovation, and national strategy. It is a prime example of how historical legacies, combined with contemporary policy initiatives, shape the trajectory of a nation's development. Answer this question in comments. The correct answer will be given hot and pinned. Lastly, we just want to let you know that we are a newly emerging online platform for competitive exams. Creating educational explainer videos like these requires a lot of effort, money, and time. If you like these videos and want us to excel and create videos in all categories of competitive exams, then you can consider supporting us with a one-time donation through the Ko-fi platform and also by becoming a member through Patreon. This will help us create more such informative educational videos in the competitive exams space. So, one last time, subscribe and share this channel with all your friends who are preparing for competitive exams. And also, follow us on social media platforms. The links are given in the About section of the channel and also in the video description. So, see you in the next video.